Hello everyone. In this video, we are going to look at 6.2a periodicity, variation of size of species on the periodic table across period. So we are going to look at how the size of atoms, the size of atoms in the periodic table varies. So at the end of this topic, you should be able to explain the variation of atomic radii across period 2 and period 3. So here we have period 2 elements. We have period 2 elements. Okay. They are all in period 2 and they are in different groups. Okay. And here are the sizes of the elements of period 2. Okay. So the size here have the unit of angstrom. So you do not need to familiarize yourself with the unit. It's just a unit, but the number here we can see how they differ from one another. So, and here we have period 3, elements of period 3 on the different groups, and here are the elements, and here are the atomic radius, or the plural is atomic radii. Okay, so let's have a look down. Okay, so before we can explain this variation, if we look on period 2 here, as the group number increases, meaning that we are going from group 1 to group 18, so in the periodic table, we are going from left to right, okay? So of the periodic table, of the periodic table, okay? So from left to right, we can see that the size, if we go down here, size becomes smaller. So size decreases. Okay, so the size decreases. Size decreases. Okay. Similarly, in period 3, as we go from left to right of period 3, as we can see here, the size becomes smaller. So size decreases as well. Okay, so let's have a look at why this is the case. Before we can explain this, we need to know how the size of atoms or atomic radius is, how they are measured. So the way the atoms, the way the radius is measured is not as simplified as you can with a normal sphere, because we know that atoms have electron clouds. Okay, these electron clouds is what we call orbitals. So this is what we call orbitals. So the shape, the boundary, sempadan atom itu is not clearly defined. But what they can do, what scientists have done, is that they take two atoms of the same type, so two identical atoms. So they measure the nucleus. So this is where the nucleus is. This is where the two nucleus and this is also nucleus. Okay, so they take the distance between the two nuclei and then they divide by 2. So that's how you get the atomic radius. Okay, so that's how they measure the atomic radius of atom. There are two major factors. So in order for us to explain this variation, we need to know what factors affect the atomic size. So there are two major factors that contribute to the variation in size of atoms in the periodic table. So the first one, written down in green, is what we call as effective nuclear charge, written with a symbol ZEF, Z effective. And the second one is what we call shielding effect. So let's have a look at effective nuclear charge. So effective nuclear charge, okay, so effective nuclear charge, what it is that it is the charge actually felt by outermost electrons. So what charge here am I talking about? So this is the positive so this is the positive charge. So this is the positive charge exerted by the nucleus. As we know, the positive charge is exerted by nucleus towards the electrons. So what they do is that the nucleus attracts. So the nucleus attracts electrons towards itself. So if we have nucleus here, so let's say we have electrons there. So this is the electrons. Okay, so this is attraction. Okay, so it is the charge actually felt by outermost electrons. Okay, so this is what effective nuclear charge is. The outermost electrons do not feel the same strength of attraction towards the nucleus due to the interaction with other electrons. Okay, so in atoms, as we know, we do not have just one electron. Kita ada lebih daripada satu elektron, lebih daripada satu proton. Apa yang proton itu buat? Okay, apa yang proton itu buat? Proton akan tarik elektron. Tapi elektron ada banyak. Apa yang elektron buat? Sebab dia ada banyak dekat dalam tempat yang kecil, elektron, they have the same charge. They are negatively charged. So what they do is they repel each other. So electron repel each other. Okay, and because of this, the outermost electrons do not feel the same strength of attraction towards the nucleus. We can calculate the effective nuclear charge using this formula. ZEF is equals to Z minus S, where Z is the proton number and S is the core electron. So let's have a look in this diagram, in this simple diagram. So this is not the actual model of an atom as we know, but this is a simplified diagram. So this is an atom of magnesium, which has a proton number of 12. And this is the electronic configuration. So here I have 1, 2 electron in the first shell. Here I have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell, the 2s2, 2p6, and then I have 3s2 in the third shell here. So what happened in this atom is that, so I am going to use the highlighter to show the attraction between the proton. So the proton is in the center, so it will attract these electrons here. It will also attract the electrons in the second shell. So it will try to attract all these electrons, and it will also try to attract the outermost electrons. Okay, so by right, sepatutnya semua elektron dapat merasai charge positif 12. Kenapa positif 12? Sebab proton number adalah positif 12. Okay, so the proton number is positive 12. However, I'm going to use the pink color. However, the electrons, apabila dia cuba ditarik oleh proton, dia nak cuba datang dekat, apa yang berlaku? Dia akan mengalami daya tolakan, repulsion between electrons. So this is the repulsion. The red one is repulsion. Repulsion. The blue one is attraction. Okay, so the electron will repel each other. So all these electrons will repel each other, and this will also repel each other. Okay, so elektron yang paling luar ini sebab ada banyak elektron di dalam ini, cuba tolak dia jauh-jauh, elektron dekat luar ni akan merasai charge positif yang kurang. So it's going to experience less than positive 12. It will experience, so the outermost electron will experience less than positive 12 charge. Okay, so lagi banyak shell, kalau kita boleh tengok dekat sini, kalau atom itu lagi banyak shell, elektron dekat luar ini dia akan rasa lagi sedikit positive charge yang exerted by the nucleus. Okay, so the outermost electron will experience less than positive 12 charge here. So charge yang dirasai ini kita boleh kira guna this formula. So for this atom, okay, so kita kena gunakan proton number dan core electrons. What core electron is the electrons yang bukan pada shell paling luar. So electrons that are not the outermost electrons. So kalau kita tengok dalam rajah di sini, elektron paling luar terletak pada shell ketiga, N sama dengan 3 here. Okay, so this is the outermost electron. Therefore, the core electron is this one, core electrons. Thus, in order for us to find the effective nuclear charge, ZEF is equals to 18, is equals to 12, because the 12 here, proton number 12, minus core electrons here, kita ada 2 tambah 2 tambah 6, 10. We will get positive 2. So in magnesium atom, the outermost electrons of Mg experience positive 2 charge. Experience positive 2 effective nuclear charge. Okay, all right, so here is example 1. So what I want you to do is I want you to pause this video right now before you proceed, for you to try yourself with the example. Okay, so let's have a look at how we can calculate this. So the first step is we need to write the electronic configuration so that we can know the core electrons. So for sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so here the outermost shell is shell number 3. So outermost shell is here. This is outermost. Therefore, this is the core. Thus, effective nuclear charge for sulfur, the effective nuclear charge experienced by the outermost electrons of sulfur is 16 minus 10, positive 6. For neon, 1s2, 2s2, 2p6. Okay, so the effective nuclear charge here is, kalau kita tengok di sini, core dia adalah shell pertama. Cara kita nak tengok core, kita tengok shell yang di dalam. Okay, so here we have 10 minus 2, positive 8. And then the last one, we look at carbon, has proton number of 6, 1s2, 2s2, 2p2. So the effective nuclear charge here is 6 minus core electron is 2. This is the core. Positive 4. So these are the effective nuclear charge of the corresponding examples. Okay. So this is the first factor that can affect the atomic size, effective nuclear charge. The second one is what we call shielding effect. So this shielding effect is related to the effective nuclear charge. Okay, so apart from shielding effect, it is also known as screening effect. Okay, this is due to the electron repulsion in an atom, seperti yang saya tunjuk dalam rajah sebelumnya here. Okay, as we know that electrons repel each other. The effect of electron repulsion between electrons from different shell is greater than the repulsion between electrons of the same shell. So maksudnya, kalau kita tengok di sini, repulsion between shell kedua dengan shell ketiga punya elektron adalah lebih kuat berbanding repulsion between electrons yang dekat dalam shell yang sama. And because of this, more shells that we have in an atom filled with electrons, the greater the shielding effect. Okay, so lagi banyak shell, lagi strong shielding effect. Okay, so here is a diagram. So kalau kita tengok outer electrons here, dia ada slight repulsion saja, tapi repulsion between shell yang berbeza lebih kuat. Okay, so now we know that these are the two effects that we have, two factors that we have. The first one is effective nuclear charge, the second one is shielding effect. So we can use this to explain the variation of atomic radius across period. So let's have a look here dalam period 2 yang saya tunjukkan tadi. So here is period 2, group 1 lithium, group 2 beryllium, 13 boron, 14 carbon, 15 nitrogen, 16 oxygen, 17 fluorine, and 18 neon. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So kalau kita tengok, this is across period. So this is what we call as across period. Okay, merentasi color. So dia berentas color daripada kiri ke kanan. Kalau kita tengok di sini, saiz dia semakin mengecil. Okay, saiz dia semakin mengecil. So let's have a look at why this is the case. So kita buat satu persatu electronic configuration. Lithium proton number dia adalah 3. Jadi dia adalah 1s2 2s1. Beryllium proton number 4 1s2 2s2. Boron is 5 1s2 2s2 2p1. Carbon 1s2 2s2 2p2. Nitrogen 1s2 2s2 2p3. Oxygen 1s2 2s2 2p4. Fluorine 1s2 2s2 2p5. And neon 1s2 2s2 2p6. Okay. So kalau kita tengok dalam periodic table, across period, bilangan shell yang diisi dengan elektron adalah sama. So kesemua ini, all of these, all have the same number of shells filled with electrons. Okay, so kita nak explain size daripada lithium ke neon semakin mengecil. Cuma kalau kita tengok dekat sini, fluorine dengan neon ni dia ada ralat sikit lah. Dia bukan ralat, dia ada keganjilan di situ. Okay, so kita ignore saja. Secara umumnya kita tengok daripada kiri ke kanan across the period, the size becomes smaller. Okay, kita tahu ada dua faktor yang boleh memberi kesan pada size. Yang pertama adalah effective nuclear charge, yang kedua adalah shielding effect. Kalau kita tengok pada shielding effect dia bergantung pada bilangan shell, because the more shell, greater shielding effect. Jadi kalau bilangan shell sama seperti kita lihat di sini, bilangan shell dia adalah sama, kita tak boleh explain menggunakan shielding effect. Jadi kita cuma boleh explain menggunakan ini, effective nuclear charge. Okay, so we want to explain using effective nuclear charge. Kalau kita nak explain guna effective nuclear charge, kita kira dia punya ZEF. Okay, so ZEF dia, yang ini lithium 3, core dia bersamaan dengan 2. Ini semua core dia. Kalau kita tengok bilangan core elektron dia dalam period yang sama, bilangan core dia sama. Outermost shell dia adalah shell kedua. Ini semua adalah outermost shell dia. So this is what we call as the outermost shell. Okay, yang warna hijau ni. Jadi core dia semua sama. Maka nak kira ZEF dia, kita tengok proton number iaitu 3. 3 tolak 2 bersamaan dengan positif 1. Kalau kita tengok yang beryllium pula, proton number 4 tolak core dia 2 sama dengan positif 2. So ZEF 5 tolak 2 positif 3. ZEF 6 tolak 2 positif 4. ZEF 7 tolak 2 positif 5. ZEF 8 tolak 2 positif 6. ZEF 9 tolak 2 positif 7. Dan ZEF 10 tolak 2 positif 8. Okay. Jadi kalau kita tengok from left to right across the period, Okay, bilangan shell dia sama. Okay, so bilangan shell dia sama, tapi dia punya effective nuclear charge berbeza. So from left to right, the effective nuclear charge increases. Bermaksud elektron kat luar, semua elektron ini, makin saya turun bawah, makin kuat daya tarikan yang dirasai oleh elektron terhadap proton ataupun terhadap nukleus. Therefore, as we can see the explanation here, going across period 2, okay, kalau kita tengok proton dia punya, kalau kita tengok benda pertama going across period 2, okay, benda pertama yang meningkat adalah dia punya bilangan proton. Okay, so the proton number increases. Okay, thus the effective nuclear charge increases. Okay, all right, so because the effective nuclear charge increases, okay, the outermost electrons, the strength of attraction experienced by the outermost electrons. Okay, the strength of attraction experienced by the outermost electrons towards its nucleus increases. So kita tahu kalau kita merentasi color 2, so going across period 2, proton number increase, and because the proton number increase, the effective nuclear charge increases. Because of the effective nuclear charge increases, the strength of attraction, daya tarikan yang dirasai oleh elektron yang paling luar terhadap nukleus semakin meningkat. Okay. As a result, the outermost electrons are located closer to the nucleus. Okay, disebabkan daya tarikan yang dirasai makin kuat apabila kita merentasi color, maka elektron paling luar, kalau kita merentasi color, dia akan terletak lebih dekat dengan nukleus sebab daya tarikannya makin kuat. Thus, the size decreases as we across the period. As we cross the period. Sorry. So the size decreases. So the size decreases across period 2. Okay. So kalau dalam soalan usually dia akan minta untuk kamu explain trend. Okay. Dia minta kamu explain trend size across period. Jadi kalau dia minta kamu explain begitu, these are the following points that you have to talk about. Kalau across period, kita kena cakap pasal proton number increase. Kita kena cakap pasal proton number. Kita kena cakap pasal proton number increase, maka dia punya effective nuclear charge. And then kita kena cakap pasal strength of attraction, okay, increases tu. Tapi ayat kena lengkap dan jangan kamu guna effective jangan kamu guna ZEF dalam explanation. Kamu kena guna effective nuclear charge. Okay. Alright. And because of this, kita kena cakap pasal closer to the nucleus, size decreases. Okay. So ini adalah poin-poin utama yang kita akan gunakan untuk explain variation of size across period. Jadi kita boleh gunakan cara yang sama untuk explain kenapa size dalam period 3 pun sama juga. Dalam period 3 kalau kita tengok size dia makin mengecil di sini. Okay, the size becomes smaller except for the group 18 lah. Group 18 ni ganjil sikit. Kalau kita tengok size dia makin mengecil. Jadi kita boleh guna cara explanation yang sama. Kita cakap going across period 3, proton number increases, thus effective nuclear charge increase. Memang macam tu. Kalau kita go across period, memang proton number akan meningkat dan disebabkan oleh itu effective nuclear charge pun akan meningkat. Okay. Kita tak nak cakap pasal shielding effect di sini, kita tak nak cakap pasal shell. Sebab kalau kita tengok shielding effect yang ditunjukkan oleh core electron sini kekal sama. Okay. So kita cakap pasal effective nuclear charge and these are the points that we need to use. So going across period 3, proton number increases, thus effective nuclear charge increases. The strength of attraction experienced by the outermost electrons towards the nucleus increases from left to right across the period. As a result, the outermost electrons are located closer to the nucleus. Thus, the size decreases across period 3. Maka itu sahajalah yang explanation yang kita boleh gunakan untuk menjelaskan variasi size of atoms across the period. Okay, so itu sahaja untuk dalam video ini. Okay, so that's the very sorry. Okay, so that's all for this video. Okay, so I hope you understand this video. Kalau tak ada soalan, sila tanya saya. Okay, before we proceed with the next one. Untuk chapter ini tak banyak sangat pun kiraan cuma ZEF sahaja. Okay, dan ZEF ini kalau kamu nak bagi explanation, tak perlu sertakan kiraan pun melainkan dia minta. Okay, tak perlu sertakan. Okay. Alright, so that's all for this video. Thank you very much. I hope you enjoyed this video.